asked to find the projection of u along v. So here that we're just practicing finding projections. So let's recall the formula for projection. So projection, or u parallel, is going to be equal to u dotted with the unit vector pointing in the v direction and times the unit vector pointing in the v direction, which this turns out to be u dot v over magnitude of v squared, and then times v again. Okay, so we're just going to plug in those vectors and the magnitude of v in there. So u parallel is going to be equal to, u is given by -1, 2, 0, and we're going to dot that with 2, 0, 1. Okay, so that's on the top. And then on the bottom we have the magnitude of v squared, so we're just going to square the components of v. So we're going to square 2, square the 0, and square the 1. And we don't need the square root sign because this squared here cancels that out. And then we just have to write 2, 0, 1 on the end for our v vector. Okay, continuing, if we compute the dot product on top, we get a -2 plus a 0 plus another 0. So then we have, that's on the top, and then on the bottom is 2 squared plus 1 squared, so that's a 5. And then we have our 2, 0, 1 tacked down to the end. So u parallel, or our projection of u onto v, is going to be -2 over 5 times 2, 0, 1, which we can distribute that in, and that'll turn out to be -4 over 5, a 0, and a -2 over 5. Okay? So that's going to be our projection of u along v.